In this section, we're going to begin our discussion on capital budgeting. Capital budgeting is an integral part of corporate finance. If a company has some money on hand, what's the best way to use that money? That's the basic question capital budgeting deals with, and here we're going to discuss a few methods to answer that question. How should a company like Tesla decide what type of investments to take on? Should they keep their focus on manufacturing personal vehicles, or should they purchase the assets necessary to expand their business into making semi-trucks? That's a capital budgeting decision. Or if Amazon's considering whether or not to purchase Whole Foods, that would be a capital budgeting decision. In both of these situations, a company's trying to decide if they should allocate some of their funding toward a specific project. And to answer that question, we need to go through a series of steps. We've already done step 1, which is determining the company's cost of capital. The next step would be to estimate the benefits that are expected to come from the project. And lastly, you would weigh the costs against the benefits to make a decision. We're going to jump to step 3 here, and we'll come back to step 2 in the next section. Before diving into the decision-making process, we need to distinguish between two different types of projects: independent projects and mutually exclusive projects. Differentiating between the two types is going to play a role in the decisions we eventually make. First, independent projects. A project is considered independent if our decision to undertake it is not affected by other projects. The decision can be made completely independent of other projects. As an example, we can look at a hotel developer. Let's say they have 2 pieces of vacant land they can build on, and they have plans to build different types of hotels, a 30-story hotel and a 100-story hotel. Since there's 2 plots of land, they have the ability to build the 30-story hotel or the 100-story hotel, or they could build both if they wanted to. If they choose to build a 30-story hotel, that doesn't affect their ability to also build the 100-story hotel. They're completely independent projects. Contrast that with the mutually exclusive project. With the mutually exclusive project, your ability to undertake a project is impacted by other decisions. Going back to the hotel example, let's assume there's just 1 piece of vacant land instead of 2. If this is the case, then there's no way we could build both a 30-story hotel and a 100-story hotel at the same time. The decision to build the 30-story hotel eliminates the ability to build the 100-story hotel. So these 2 projects are mutually exclusive. There are many different ways to evaluate whether a company should accept or reject a project, and we're going to discuss 5 of them. In this video, we'll go over the net present value and internal rate of return and leave the rest for future videos. We're going to be evaluating 2 projects, Project S and Project L. Project S has an initial cash outlay of $3,000, which means we'll have to spend $3,000 to get the project started. After that, we'll receive $1,500, $1,200, $800, and then $300. With Project L, we'll have the same $3,000 initial cash outlay, and we'll receive $400, then $900, $1,300, and then $1,500. For both of these projects, we'll assume that the company's cost of capital is 10%. We're going to try to make some decisions. Which of these projects should we do? Project L or Project S? Or should we do both of them? We'll use project evaluation tools to help us make these decisions. And we'll start with net present value, NPV. Net present value is going to tell us how much a project is worth. Like the name suggests, we're going to find the present value of all the project's cash flows from time 0 until the end of the project's life at time n. This should look like a pretty familiar formula. We used it when we valued stocks and bonds, but we had a little subtle difference. We said the value of securities is equal to the present value of the future cash flows. But in this formula, notice that we're starting with the cash flows from time 0. We can rewrite the formula to stress the net aspect of net present value. When we find the net of something, it means we subtract something. Net income is the income left over after subtracting expenses. Net weight of some food at the grocery store would be the weight minus the packaging. Here, the net in net present value means we'll take the present value of the project's future cash flows and subtract the initial outlay. That's the cash flow at time 0. Once we compute a value for NPV, we need to make a decision. And we have a very simple decision rule. If the projects are independent, meaning if we choose to do one, we can also do the other, we would accept all projects that have a positive net present value. And for mutually exclusive projects, we'd first check whether the projects have a positive NPV. If they do not, we'll reject them outright. If they do have positive NPVs, then we would select the project that has the largest NPV. To find the NPV of project S, we could put all of its cash flows on a timeline and find the present value of each one and finally add them together. Doing that gives us an NPV for project S of $161. We can do the same for project L. We find out that it has an NPV of $108. It's possible to do these computations by hand, but it can get pretty tedious, especially if you're dealing with numerous cash flows. So we can use a calculator or Excel to do the heavy lifting for us. With the TI-83 calculator, we'll go into Applications, then Finance, and scroll down to NPV. From there, you'll enter the following syntax. First, the interest rate, or the cost of capital. That was 10% for us. Next, enter the cash flow at time zero. That's the initial outlay of $3,000. We'll put it in as a negative. Then you'll use the curly brackets and enter the future cash flows as they appear on the timeline. We get $1,500, then $1,200, $800, then $300. Finally, close the curly brackets, close the parentheses, and hit enter. And we get an NPV for project S of $161. In Excel, we do something pretty similar. The NPV function in Excel will compute the present value of the future cash flows. That is the present value of the cash flows at time 1, 2, 3, and 4. But it does not include the cash flow at time 0, the initial cash outlay. So to find the net present value of the project, we'll use the NPV function and enter the interest rate, and then the cash flows at times 1, 2, 3, and 4. Then we add to that the initial outlay, the cash flow at time 0. And we get a net present value of $108. Now that we computed the NPV for both projects, it's time to use that information to make a decision. Which of these projects should we accept and which should we reject? Let's first assume these projects are independent. Remember what it means to be independent. That means if we choose to do project S, that decision will not affect our ability to also do project L if we wanted to. If S and L were independent projects, then we would accept both of them. They both have a positive NPV, so our decision rule says we should do both of them. But why is this the rule? Well, a positive NPV project will add value to the company. Think about what's happening when we compute NPV. We're comparing the value of the future cash flows against the initial cost. So a positive NPV means the project's benefits exceed the costs, so it's going to add value. The NPV project is a direct measure in dollar terms of how much value will be added to the firm. So if project S has an NPV of $161, it's expected to add $161 of value to the company. A negative NPV project would reduce the value of the firm. If the objective of the corporation is to maximize the wealth of the owners, then the company should accept all projects that add value to the company. So they should accept all positive NPV projects and reject negative ones. Let's consider the case that S and L are mutually exclusive this time. If we do one of the projects, then we can't do the other. If that's the case, then we would accept project S and we would reject project L. The reason is project S will increase the value of the company more than project L will. So if we can only do one of them, we should select the project with the largest NPV. Another method to evaluate projects is by using internal rate of return, or IRR. The IRR will tell us the average rate of return on the project. So in that sense, it's very similar to the yield to maturity on a bond. To compute IRR, we're going to start with the NPV formula. And we want to find the interest rate, R, that will make the first term, which is the sum of the present value of the future cash flows, equal to the second term, the initial outlay. Said differently, we want to find the interest rate that forces the net present value to equal 0. That rate will be the internal rate of return. How can we use IRR to make decisions? Well, for independent projects, we would accept all projects that have an internal rate of return that is greater than the project's cost of capital. And for mutually exclusive projects, if all of them have an IRR greater than the cost of capital, we select the one that has the greatest internal rate of return. Now let's compute the IRR for project S and for project L. As I said earlier, the IRR is going to be the interest rate we put into the NPV formula that forces the net present value to equal 0. This can be very difficult to do by hand, but luckily our technology can handle this for us easily. In the TI-83 calculator, we can use the IRR function in the finance apps. We first enter the initial outlay, the negative $3,000 cash flow at time 0, and a comma, and some curly brackets. Then we enter the future cash flows as they appear on the timeline. 1,500, then 1,200, 800, and 300. Close the curly brackets and the parentheses, and hit enter, and we get 13.11%. That's Project S's internal rate of return. This means this project will generate, on average, a return of 13.11% per year for the company. We can compute Project L's IRR in Excel, and this is really simple. We'll use the IRR function and select all the project's cash flows from the initial outlay all the way to the final cash flow at time 4. And we get an IRR of 11.38%. Now we need to make a decision. Which of these projects should we accept? If Project S and L are independent, we would accept both. Both of the IRRs are greater than the cost of capital. Why is this the decision rule? An IRR greater than the cost of capital implies that the project's return outweighs its cost. For example, for Project S, we'll get a 13% return, and it's only going to cost us 10% to get the money to do the project. So obviously, it's worthwhile. If we're able, we would accept all projects with an IRR greater than the project's cost of capital. If S and L are mutually exclusive, we would accept S and reject L. They both have IRRs greater than the cost of capital, but the internal rate of return on S is larger than the internal rate of return on L. So if we could only choose one project, we would choose the one with the biggest return. I want to quickly touch on an issue that pops up from time to time. What if you're evaluating a project and get conflicting outcomes from the NPV and IRR decision rules? For example, the NPV rule says accept the project, but the IRR rule says reject. If that turns out to be the case, then you should always follow NPV. Remember, NPV tells us how much the project will increase the value of the company and thus how the owners will be impacted. And that directly aligns with the objective of the corporation. So whenever there's a conflict, the default should be net present value.